So here we are with another question on diode current equation, and the question is, a germanium diode draws a current of 40 milliampere with a forward bias voltage of 0.25 volt. The junction is at a temperature of 293 kelvins. Calculate the reverse saturation current of the diode. Okay, so like we do with all the questions related to diode equations, we have to first write the diode equation, only then we can proceed. So this is the diode equation. Okay, so here what is mentioned in the question? First, the diode type is germanium, which means the ideality factor will be equal to 1. Then the diode current is given, which is equal to 40 milliampere, which is equal to 0.04 ampere, that is given. The applied voltage, forward bias voltage, that is equal to 0.25 volt, that is given. And here the question which is asked is to find out this reverse saturation current. And here there has been another thing which has been mentioned, is that the junction is at a temperature of 293 Kelvin. Now in all the previous questions it was given that the junction is at room temperature, or the diode is at room temperature, and we used to take the thermal voltage as 26 millivolt. Okay, whenever room temperature is mentioned, we always used to take this value equals to 26 millivolt. But here specifically it has been given that the temperature of the junction is 293 Kelvin. So here we cannot take this. Here we have to use a formula which is related to this thermal voltage. So Vt is called as thermal voltage, and it is also called as volt equivalent of temperature. Okay, volt equivalent of temperature, and it is given by the temperature in Kelvin divided by 11,600. This. So here we have to calculate the thermal voltage or volt equivalent of temperature for T equals to 293 degree Kelvin, which is equal to, if we calculate 293 divided by, it is coming around 0.0252 volt, 0.0252 volt, or it is equal to 25.2 millivolt, or equal to 25 millivolt. Okay, this. So here if we had taken 26 millivolt, the result would have been different, and for this reason here it has been mentioned specifically about the junction temperature. It has not been mentioned that the junction is at room temperature. If it would have been mentioned room temperature, then we would have taken 26 millivolt, the thermal voltage. So whenever room temperature is mentioned, take this value. If specifically the temperature is given, calculate the volt equivalent of temperature or the thermal voltage using this formula. Okay, so now everything is clear. We have to simply put the value and get the result of I0. Okay, so here if we put the values, I is equal to 0.04 ampere, I0 e to the power V, which is 0.25 divided by ideality factor 1 into thermal voltage, which is 0.02525 minus 1. That implies I0 is equal to 0.04 divided by this. So we are getting the result as so it is coming around 2 microampere, 2 to the power 10 to the power minus 6 ampere, which is equal to 2 microampere. This is the result. So here in this question, the important concept was this: the volt equivalent of temperature. This is the important concept here to understand. Here everything was straightforward, all the values were given, but the tricky part here was that it was mentioned that the junction is at a temperature of 293 Kelvin. So we cannot take this value, just like that. There is a reason why it has been mentioned that the temperature is 293 Kelvin and not mentioned that the junction or the diode is at room temperature. So for that we have to calculate the thermal voltage at this temperature specifically, and then we can put that value in the diode equation, and remaining is just basic calculation, and we got the result. Okay,